Hello everyone, let's continue our discussion in the course Introduction to Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In this week, we started our discussion around decision making. In the last lecture, we talked about the need to incorporate economic decision making, more importantly keeping in mind the life cycle perspective. Now, we will continue our discussion and will discuss multi-criteria decision making. This is the second lecture in the fifth week where decision framework for infrastructure asset management is discussed. Here we will be discussing multi-criteria decision making. We will discuss a method known as AHP. My name is Chirag Kothari. I am assistant professor in the Department of Civil Engineering at IIT Kanpur. Now, before we start discussing AHP, let us discuss why do we need multi-criteria decision making. Till now, in this course, we have seen that for asset management, we need to ensure that the asset's performance doesn't go below the critical performance level during its service life. The goal is to maximize performance. Here, we have seen that performance of an asset can be defined in several manners. There are multiple ways of defining performance of an infrastructure asset. Moreover, we have discussed that in addition to performance, we need to account for sustainability, which includes people, planet and profit, or economics, environment and equity. We also need to ensure that the infrastructure we develop is resilient and it is adaptive to climate change. Further, we have briefly discussed that we need to come up with a way which involves data-backed decision making. Now, one question which might arise here is, there are so many criteria which needs to be taken care of. How do we take decisions? Since there is no single criteria which can be used for decision making, how should we take a well-informed data-backed decision? This is where multi-criteria decision making tools are helpful. In this particular lecture, I will be discussing one such method which is known as Analytic Hierarchy Process or AHP. It is a well-known multi-criteria decision making approach. AHP or Analytical Hierarchy Process is a widely adopted method in multi-criteria decision making. It was developed around 1970s by Thomas L. Satie. This method provides a structured, systematic approach to breaking down complex decision problems into manageable hierarchical components. Here, the approach uses both math and psychology to come up with a method for doing multi-criteria decision making. The emphasis here is that humans naturally possess the ability to make comparative judgments and they can express varying intensities of preference. This has been the major premise on which AHP was developed. I will just talk about this with the help of an example. Say you have to take a decision based on 4 criteria, C1, C2, C3 and C4. Now, if I ask you to assign relevant weights to each of these criteria, it might be difficult. It might be difficult for you to say that C1 is 30% important, C2 is 20% important, C3 is 10% important and C4 is 40% important. This is a difficult exercise, especially when multiple stakeholders are involved. Now, alternatively, if I just ask you that please compare only criteria 1 and criteria 2 and let me know which criteria is more preferred and at what scale. Probably this is relatively simple. You can compare 2 criteria and decide which criteria is more important than the other. This is the premise of AHP. I hope this idea will get clear when we discuss a real world example. AHP is a powerful tool because it can handle multiple criteria. At the same time, it can handle multiple perspectives and multiple stakeholders. It is flexible for both tangible and intangible factors. Moreover, if there are uncertain outcomes, AHP can even handle that. It basically involves a process where we do hierarchical decomposition, then we do pair-wise comparison, then we synthesize the judgments, and finally we check for consistency. We will discuss the steps involved in AHP in detail with the help of an example of choosing a car. Say you have multiple options. You want to choose one of these cars. It can be a hatchback or a SUV or a different segment. Now the question is, can you come up with a structured method to choose the right car? We will learn this with the help of AHP. AHP involves 5 key steps. The first one is where you structure the hierarchy, or we basically decompose the problem. Second step is pair-wise comparison of criteria. Here we identify all the relevant criteria, and by doing so we understand what is the priority of one criteria over another. Then the third step involves pair-wise comparison of alternatives on each criteria. Now each alternative is compared on each criteria, and then we synthesize the result, and finally we move towards consistency checks. These are just 5 broader steps. I will discuss each of them in detail one by one. Let us start with step 1, structuring the hierarchy or decomposing the problem. From our example, we try to first understand what are the goals, what are the relevant criteria, and then what are the alternatives available. So for any problem, it is simple to understand what is the goal. For example, in case of car, our goal is to select the right car for our personal use. Now tier 2 basically involves coming up with relevant criteria. Sometimes there can be sub criteria as well. So we try to understand that what will be the criteria for our decision making. This is an important step. One should identify all the criteria which are relevant for them. Then the third tier is basically the alternatives which are available. So this in our case would be, say, car 1, car 2, car 3, or we can say hatchback, SUV, sedan, and so on. So basically we have written the problem in a manner where we know the goal, we try to identify all the relevant criteria and sub criteria, and we find all the possible alternatives. So in our case, for selection of a right car, what could be some of the relevant criteria? Think about it. Say you need to purchase a car. What will be the relevant criteria which you would keep in mind to make this decision? Before moving on with the video, please make a list of all the relevant criteria which comes to your mind. I hope you have thought about it. Let us say that the 4 criteria on which we want to take a decision are as follows. First is safety. We want a car which is safe to drive. Second, we want a car which is reliable. So reliability. We don't want a car which breaks down quite often. We want a car which is reliable. Third is economics. We want a car which is economical, both in terms of the initial cost as well as maintenance and operations cost. And finally, fourth criteria which is relevant for us is, say, style. Now we have discussed that I want to purchase a car and I have these 4 preferences. I want a car which adheres to safety, which adheres to reliability, which is economical, and I also have a preference around style. Now, as I told you earlier, if I ask you, can you assign weights to these? So can you say that in my overall decision, safety is 20% important or style is 30% important? This is difficult because one cannot do this objectively without using a structured approach. This is where AHP is helpful. I will discuss how. The goal or the first step within AHP is to assign weights to each of these criteria, but we do this in a structured manner. Moving on, for the first example, once we have identified all the relevant criteria, the next step would be to identify all the relevant alternatives. So, say we have 4 alternatives: car 1, car 2, car 3 and car 4. I have just written some segments here. For a real world example, you can actually have specific names of the car which are under consideration. So, this is step 1, where we have decomposed the problem. We have identified the goal, we have identified all the relevant criteria, and we have also identified all the relevant alternatives. Now, step 2 involves doing a pairwise comparison of these criteria. So, you want to do priority setting. In step 2, we try to understand the relative importance of each criteria. Here, we try to use a fundamental scale which was developed by Satis, where we say that if 2 criteria are equally preferred, then we give a number 1. However, if a second criteria is moderately preferred over the first one, then we give a number 2. On the extreme side, we give a number 9 if a given criteria is extremely preferred over another. Similarly, on a scale of 1 to 9, we can give 4 for moderately to strong preference, we can give 7 for strongly to very strong preference, and so on. So, this is a scale which is used. The way we do comparison is as follows. We try to create a pairwise comparison matrix. If you look carefully here, each criteria is listed in rows as well as columns. So, the 4 criteria which we have for our decision were safety, reliability, economy and style. I have listed them in columns as well. Now, we try to ask a question which is on the lines of how important is safety over reliability, or how important is safety over economy, and we try to answer this question on a scale of 1 to 9. Now, since there are multiple stakeholders, we can ask each one of them for their preference. So, in this particular case, for example, I start with how important is safety over safety, or how much do you prefer safety over the safety criteria. Obviously, here since we are talking about the same criteria, we can just say both of them are equally preferred. I hope this makes sense, that the diagonal of the pairwise comparison matrix will always have 1. Now, let us talk about the preference of safety over reliability. Now, if someone asks, if you compare a car on its safety and reliability, what is more important to you? So, someone could say that, okay, for me on this particular scale of 1 to 9, safety is around 3. So, I am saying it is moderately preferred over reliability, because I do want a reliable car as well. Now, what is the preference of safety over economy? One could say that safety is much more important for me. When compared with economics, I would actually prefer safety. So, say they give a number of 7. So, 7 is somewhere here between strongly preferred to extremely preferred. So, you are saying that safety is more preferred over economy. Finally, when it comes to style, we could say that similar to economy, even for style, safety is 7 times more preferred than style. Similar to the previous case, even safety has a preference over style by a factor of 7.0. Now, let us move on to the next row. Now, we have to assess how important is reliability over safety. Here, please note that we have already said that safety over reliability is 3.0. Now, If I ask the question in a reverse manner, where what is reliability over safety? The answer should be 1 divided by 3.0. So, once we have filled the first row, the converse or inverse can be filled directly like this. Similarly, I can say that since safety had a preference of 7 over economy, economy will have a preference of 1 divided by 7 over safety. Similarly, since safety had a preference of 7 over style, style will have a preference of 1 over 7 over safety. I hope this is clear. However, when it comes to what will be the number in this particular cell, here we are saying how important is the reliability over economy. We have not assessed this till now. So, we try to assess this. One could say that when it comes to economy and reliability, both of them are preferred. I want a car which is economical, at the same time reliable. I do not have any major preference of one over another. In that case, we can just write 1.0. Moving on, if I have to assess how important is reliability over style. So, the question is that on a scale of 1 to 9, where 1 is equally preferred and 9 is extremely preferred, how much do you prefer reliability over style? Say I say 5. That is, I have a moderately strong preference for a reliable car over a stylish car. Once we have these numbers, similar to the previous case, economy over reliability will be 1 divided by 1, because we have already assessed reliability over economy to be 1. Now, style over reliability, we have already assessed that this will be 1 divided by 5. Style over economy is something which we have not assessed till now. So, we try to assess what is the preference for having an economical car over stylish car. One could say that styles do not matter that much to me. I actually want an economical car and I give a preference of 3 here. The moment you give a preference of 3 for economy over style, obviously style over economy will be 1 divided by 3. So, I hope this idea is clear that for a pairwise comparison matrix, the diagonal will always be 1. Then we are actually trying to assess either the lower triangle or the upper triangle. So, either we try to assess these numbers. Once we have these, the remaining numbers can be determined automatically. Once you have a pairwise comparison matrix, AHP details how we can use this information to determine relative weights. Let us talk about the procedure to do that. Once we have a table like this, where all the pairwise comparisons are filled, the next step here is to determine weights, where first we do the sum of the values in each column. So, basically I try to add all the values in each column. First column will be 1 plus 0.33 plus 0.14 plus 0.14. Let us try to do that. 1 plus 0.33 plus 0.14 plus 0.14 will be around 1.62. Please note, I have done a round off here. Similarly, we do this for each column. Now, once we have done this, we divide each element by its column total. Basically, what I am trying to do here is, I am trying to find out normalized pairwise comparison matrix. So, if I do a summation of all these columns, I should get 7 plus 1 is 8, 8 plus 1 is 9, so 9.33, and for style it should be 7 plus 5, 12, 12 plus 4 is 16. Once I have this, I will try to calculate the normalized value. Normalized value is given as the value in each cell divided by the total. So 1 divided by 1.62 will be around 0.62. Similarly, 0.33 divided by 1.62 will be 0.21 and so on. The idea is to determine all these normalized values. Then once we have this, in the third step we try to find average of each row. So for safety we try to find average of all these and we will get the average criterion weight. So here I say 0.62 plus 0.58 plus 0.75 plus 0.44 divided by 4. So I get value of 0.597, let us say 0.60. Similarly, for the other values, reliability has a weight of 0.20, economy has a weight of 0.14 and style has a weight of 0.06. So I hope the idea is clear. What we have done is, once you have the pairwise comparison, we have done a summation. Then to find the normalized value, we have divided each cell's value by the total in that particular column. Then we have written that number here. For example, for reliability, 3 divided by 5.20 is 0.58. We have done this for each cell and then we have done an average of these 4 values 1, 2, 3 and 4. This has provided us the relative criterion weight for safety. Let us have a look at these values. Here what we are saying is, based on the pairwise comparison which we had done, safety is found to be 60% weightage in our overall decision. On the other hand, style has only a 6% weight in our decision. This will actually align with the way we have given pairwise comparison. The way we filled this matrix, we actually emphasized that safety is an important aspect. So this calculation has actually come up with a number which says that in your overall decision, safety should have a 60% weightage. Finally, at the end of this step, what we have is the relevant criteria weights. Finally, we have determined that safety is an important aspect and in our overall decision, we believe that it should have a 60% weightage when compared with economics, reliability and style. On the other hand, reliability should have 20% weightage in our decision. AHP has helped us in identifying these criteria weights. So in AHP, we started with the first step on identifying all the relevant criteria. We also identified the relevant alternatives. In the second step, we have determined what is the weight of each criteria. Now the question is, finally, how do we decide which car is the best? This is where we move towards the third step, where we do a pairwise comparison of the alternatives on each criteria. Here, instead of determining the weights for each criteria, our focus is on understanding the performance of each alternative on each criteria. Let us discuss step 3 of AHP. So, similar to the criteria matrix, we try to create a matrix like this for each criteria. For example, safety was one of the criteria. Here, what we have done is, we have written all the alternatives in both the rows as well as the columns. The criteria is written here. We will try to ask ourselves that what is the preference of having car 1 over car 2 when it comes to safety. So now we are trying to assess how important or how much better a given car is over another when it comes to safety. Similar to the previous matrix, even here the diagonal will have a value of 1, because we are just saying that a given car has same preference over itself. Now, let us move on and discuss the next set of cars. So, now say I want to compare car 1 over car 2. Let us assume car 1 is a hatchback car and car 2 is, say, a sedan, and you feel that sedans are more safer than hatchbacks. Now, on a scale of 1 to 9, if you have to assess this, you might say that I feel that car 2 is around 2.0, that is more or less equally preferred over car 1. Accordingly, when it comes to car 2 over car 1, it will be 0.50. Now, say your car 3 is a SUV. You might say that when it comes to safety, a SUV is actually much more safer than car 1, and say you give a number which is around 3. Basically what you are saying is that you believe SUVs are safer, but then hatchbacks are also safe because they are meeting the minimum requirements anyway. So, instead of giving a very high number here, you are actually giving a 3. Similarly, you might want to answer how much safe is car 4 over car 1. Say I give a rating like this. Now, we try to fill this particular matrix. We try to assess pairwise comparison for each case. I have written some arbitrary numbers here which are representative of how a stakeholder feels one car is safer than another. Here, for example, if you focus on this particular number here, it says that according to the user or the stakeholder, car 3 and car 4 are both equally safe. There is no preference as such. Now, we try to do this for each criteria. Once we have a pairwise comparison matrix like this, we follow the same procedure which we followed for different criteria. That is, we try to estimate the normalized values, and then we try to take an average to understand what is the performance of each car on a given criteria. So, the first step here is to do a summation. For each column, you do a summation, then you try to find the normalized value. So, basically 1 divided by 9 will give me 0.11, or 0.25 divided by 6.50 will give me 0.38. Once we have this, as we did in the earlier case, we try to find average of all these values. So, 0.11 plus 0.08 plus 0.12 plus 0.12 divided by 4, and we get a value which is 0.11. This value basically says that according to the pairwise comparison matrix, the stakeholder feels that car 1's relative performance in terms of safety is around 0.11. On the other hand, the relative performance of car 3 and car 4 in terms of safety is around 0.36. So, in this step, we have identified the relative importance of a given car on the safety criteria. However, similarly, we have 3 more criteria and we need to do the same thing. It is important to note here that all these values are actually relative performances. Since we have 4 cars in our mind and we want to estimate how much better a given car is over another, we can actually do a relative comparison. Now, once we have the relative performance of each car on the safety criteria, we can move on to do the same thing for other criteria. Here I have given the pairwise comparison metrics for reliability. If you see here, the stakeholders have probably given just 1 for all the values in each cell. This basically means that the user feels each car is equally reliable. They do not feel that one car is more reliable than another. This is a fair assessment. They might feel that each of these cars are reliable and they do not have any preference as such. So, all the numbers are 1. Now, say I move towards economy. Now, when it comes to economy, again I have this pairwise comparison matrix, where if you see, the value here is 9. In our case, we were saying that a car 1 is say a hatchback and car 3 is actually a SUV. What we are saying is that when it comes to economy, car 1 is extremely preferred over an SUV, because we believe a hatchback is actually cheaper and it is also more economical when it comes to operations and maintenance cost. So, they have given a very high preference. And similarly, for style, these numbers are filled here. If you observe this particular comparison matrix, you can actually assess that the user feels that car 4 is actually the most stylish. Obviously, this is a more subjective assessment. As we have discussed, that AHP can deal with both intangible and tangible factors. Economy is more of a tangible factor, where you can estimate the initial cost. You can also look into the mileage, maintenance cost and so on, and you can determine what is the performance of a given car over another in a tangible manner. On the other hand, style is more of a perception. The user just feels that one car is more stylish over another, and they can fill a pairwise comparison matrix like this. Now, in this particular lecture, I have not solved each of these matrices. Similar to the case of safety, where we found the normalized value and we followed the steps to determine what is the relative performance of each car on the safety parameter, I encourage all of you to do this for reliability, economy and style. You can use the numbers for pairwise comparison which are given in these 2 slides. You use these numbers to estimate what is the relative performance of each alternative. If you see here, I have already filled the numbers for safety. Your exercise is to estimate what will be the relative performance of these cars on the basis of reliability, economy and style. Before moving on to the next lecture, please try to do this. At the end of this particular step, basically we will have an understanding of what is the performance of each alternative on each criteria. In the next step, we will see how do we use this information to synthesize the results, and we will also see how to check for consistency. Before moving on to the next lecture, please try to solve this on your own and also try to see all the steps which we have discussed till now. I hope the idea of AHP is clear, and students are encouraged to go over these references if you want to learn about this particular topic. Thank you. Thanks for listening.